All right, people. I believe everybody is doing great, nice, and absolutely fine. Please let me know in the chats if I'm perfectly audible, visible to each and every single student. Okay, so we will be finishing the chapter today. That is the projectile motion, complete projectile motion. We'll try to finish this in today's part. We'll for sure finish it. So before that, I would want you guys to tell me in the chats if I am perfectly audible, visible to each and every single student. Okay. Yes, we are live. So let the people join and we are starting this session accordingly. Let everybody come. So we will start this particular session accordingly. Okay. So guys, we have some important topics left in this particular projectile motion. We finished a lot of topics in the first session, but still some topics are there which we are supposed to cover in the today's one shot. Okay. So guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Okay, because liking this session is extremely mandatory. So let's basically start the today's session. Let's basically complete this particular chapter, that is projectile motion one shot. And if you have not watched its session one, I would recommend you to guys watch that also. Okay, so let's basically start this particular session. And when it comes to this particular session, my dear friends, okay, now see, we'll try to finish this in 1.5 hours, okay, or 1 hour or more than 1 hour, okay, maximum 1.5 hours. Now guys, see, let's take a look over here. It says that relation between horizontal range and maximum height. This is the topic that we need to exactly discuss right now over here. That is the relation between range and maximum height over here. Guys, if I say, let's suppose you have launched a projectile. Over here, and this projectile falls something like this. Okay, what is the range of a projectile? We say when it comes to the range of a projectile, that means this, how far it can go from its initial position. And what is the height of the projectile? Height means how high it can go in this particular case. Okay, now could you please tell me, I have told you before, what is the relation for range and maximum height? Guys, see, when it comes to the horizontal range of a projectile, okay, and when it comes to the maximum height, maximum height attained by the projectile, how high it can go, that is, I have told you before, that is nothing but we say uy square divided by 2g, or this is also called the u square sine square theta divided by 2g. Okay, and when it comes to, my dear friends, the horizontal range, horizontal range, guys, we have to find that formula in which range is present and in which maximum height is present. Guys, horizontal range formula, it has 2 times of ux uy divided by g. This is what we call the horizontal range, and this is what we call the maximum height. And I would want you guys to divide this particular equation with this particular equation. Divide both the equations. We say, can I write over here, that will be h divided by this r, and this will be equals to, guys, I can say, what is this? This is uy square. So over here, this is uy square divided by 2g. Okay, uy square divided by 2g. And instead of this r, I would want you guys to write over here, that is 2 times of ux uy divided by g over here. Now tell me one thing. Sir, this u square and this one uy will cancel over here. This g and this g will cancel over here. Don't you think that what remains over here, that is uy divided by 2, and over here 2 times of ux, that will be 4 times of ux. Okay, guys. In this particular case, can I say, sir, this range horizontal, this maximum height and range will come out to be, that is uy divided by 4 times of ux. Now, I have told you in the last class, if you remember, let's suppose if you are launching a projectile with velocity u. Can I say that, sir, this, if this is theta, we say, sir, this is its which component, sir? This is ux component. And this one is, we say, sir, uy component. Now, could you please tell me what is the value of this tan theta over here? Sir, tan theta here is perpendicular divided by base. And what is perpendicular? That is uy. And what is base? That is ux. Okay, this divided by this. Now, can I say the same thing over here? Sir, I can say h divided by r will be, instead of uy by ux, can I write over here tan of theta? So this is tan of theta divided by 4. Now take it over there. So I can say this maximum height is coming out to be, that is r tan of theta divided by 4. So I would want you guys to put up this particular equation in the box. Why? Because this is the relation between, we say maximum height and horizontal range. This is the relation between maximum height and horizontal range. So if in a question you are given, we say horizontal range, you can find, if horizontal range is given, you can find the maximum height. Okay, so by this particular equation. Now, we will have to basically solve the questions on this particular equation that I'll be showing you over here. Is this clear? Before everything, let me know in the chats. Is this clear? Guys, tell me in the chats if it is clear to each and every single student. If this is crystalline clear to each and every single student, let me know in the chats. And if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Guys, hit the like button as soon as possible. Is this clear? Is this crystalline clear? Great. Now guys, listen to me very carefully. Let's basically take a look at this particular question over here. Let's solve this question first. Yes. The horizontal range and a maximum height of a projectile, are equal. Okay. In this particular question, we say range is given as maximum height. Both are equal. The angle of projection of the projectile is, we are supposed to find the value of theta, angle of projection. Okay. Guys, see, we have to find, we say theta. At what angle we have launched the projectile? We have to find this theta. Guys, could you please tell me in this particular case, I'll just write this equation over here. We say, as we know, we recently saw one equation. What is that? Sir, that is, we say this maximum height, this is equal to, that is r tan of theta divided by 4. Because when only range is given and you are supposed to find the height, you can basically use this equation. Now instead of r, you can put over here h. So I can say this is equal to, h is equal to, instead of r, you'll put over here, this will be h. This will be over here, that is h, and this is tan of theta divided by 4. Okay. Now, can you tell me in this particular case, this h and h will cancel, so this will go over here. So tan of theta will be equal to 4 in this particular case. Guys, can you tell me in this particular case, okay, tan of theta is equal to 4. Now, what will be the value of theta? theta I can simply say in this particular case that is tan inverse of we say 4. Tan inverse of we say 4. Okay, okay. This is basically the answer in this particular case. Now, let's take a look at the next question over here. In this question, what does it say? The horizontal range of a projectile is 4 root times of its maximum height. We say range here is given as 4 root 3 times its maximum height. Okay. Its angle of projection is, here also we have to find theta. Guys, what is the relation? As we say, as maximum height is equal to r, I'll write tan of theta divided by 4. Can I write it something like this? Yes, sir. Now guys, tell me one thing. Instead of this range, I can put, so this is h is equal to, instead of this r, I'll put 4 root 3 into, we say, sir, h, and then I'll write tan of theta divided by, we say, 4. Now this 4 and this 4 cancel, h and h will cancel. So tan of theta will come out to be 1 by root 3. Now could you please tell me at what angle the tan has, at what angle the value of tan is root 3? At what angle the value of tan is root 3? It is 30 degrees. So I can say over here tan of theta is equal to tan of 30 degrees. Why, sir? Because we know tan 30 is 1 by root 3. Either you write 1 by root 3 or you write tan 30. It's one and the same thing. So I can say theta in this particular case will come out to be 30 degrees. Is that clear? Is that clear, boys and girls? I hope everything is sorted. Now, let's take a look at this particular question. This is an important question. I would want you guys to basically keep this in your mind. This is an important question that we have over here. The speed at the maximum height of a projectile is root 3 by 2 times of its... Okay. The questioner says that the speed at the maximum height of a projectile is this. Its range is. Okay. It says that the speed of a projectile at its maximum height is root 3 by 2 times of its initial speed. Okay. And we are supposed to find in this particular case, what is the range of a projectile? What is the range of a projectile in this particular case? Okay. Now guys, this is the question that we are given over here. I would want you guys to try this out and let me know what is the answer of this particular question. Before this, I just want to show you this question. For an object with a ground speed u, horizontal range is 2 times its maximum height. The range, yes, this question. Because this is related to r tan theta. Okay, that's the reason. Okay. So in this question, it is saying that in this question, before that, I would want you guys to see this. We say for an object projected from the ground with speed u. An object is projected from the ground with speed u. We have an object over here. It is projected from the ground with speed u. Its horizontal range is 2 times its maximum height. So it will basically follow this path. And it says that its range is 2 times the maximum height. What is the range of the projectile? We are supposed to find what is the exact value of the range. What is the exact value of the range? This one. Guys, tell me one thing. If a range is given in terms of height, we are supposed to find range. Guys, see. First and the foremost thing is, I would want you guys to use this particular equation. We say, sir, maximum height is equal to, we say r tan of theta divided by, we say 4. Maximum height is equal to r tan theta divided by 4. Now see. Can I say in case of this, I'll write, instead of this r, I'll write 2h. So this is h is equal to, here I'll write 2h, and this is tan of theta divided by 4. Now this is 2 1s, 2 2s. This and this will cancel. So now this will come over here. So we say tan of theta in this particular case came out to be 2. Tan of theta in this particular case came out to be 2. Guys, see. If tan theta is 2, can I say, sir, tan theta means it is perpendicular by base. So it is 2 divided by 1. It is 2 divided by 1. Guys, I'll show you the approach over here. If tan theta is 2, means perpendicular by base. Let's make the triangle over here. So in this triangle, if I say, sir, this is theta. So this is perpendicular, it is 2, base is 1. Now, could you please tell me what will be the value of hypotenuse over here? Sir, hypotenuse is root of 2 square. How do we find the hypotenuse? 2 square plus 1 square. So that is 4 plus 1, that is root 5. So this is root 5. Okay. Now, guys, first I use this particular equation we have to find the range. Now, what is the actual formula of range? Guys, the formula of range is R is equal to, we say u square, 2u square, sine of theta, cos of theta divided by g. This is the formula of range. Guys, see. We know what is the value of u. It is saying that we have launched the projectile with speed u. So u we know. Sir, g we also know. But what is the value of sine theta and cos theta? That we didn't know. So we will calculate that with the help of this relation that I have shown you over here. Now, can I say from this triangle? So what is the value of sine of theta? Sir, sine theta is perpendicular upon hypotenuse. That is 2 by root 5. What is the value of cos of theta? I say cos theta is base by hypotenuse. That is 1 upon root 5. That is 1 upon root 5 and 2 upon root 5. Now put it over here. So I can say when it comes to the range. So I'll write over here that is 2u square. What is the value of sine theta? That is 2 by root 5. So 2 divided by root 5. And what is the value of cos theta? That is 1 by root 5. 1 by root 5. And divided by, I say, g over here. Now, guys, can I say in this particular case, this r will come out to be? Now, guys, what is this? This is 2 into 2 is, we say, sir, 4. Root 5 into root 5 is, we say, 5. So this is 4u square divided by, 4u square divided by, we say 5g is exactly the answer in this particular case. Okay. Is this clear? Is this clear? Please tell me in the chats, everybody out there. Everybody out there. Guys, tell me in the chats. Everyone means everyone. I hope this is crystalline clear. I hope this is, guys, if you have not liked this session yet, I would want you guys to hit the like button. Hit the like button as soon as possible. Okay, liking the session, marking the attendance is extremely mandatory. Okay. Yes, great. Okay, now guys, take a look over here. Let's have a look on this question now. Okay, let's have a look on this question now. In this particular question, what does it say? It says that the speed at the maximum height of a projectile is root 3 by 2 times of its initial speed. Let's suppose we have launched a projectile from this particular point. So it will follow this particular path over here. And it says that at the topmost point, its velocity is given as a root 3 by 2. Guys. From the concept itself, if you remember, I have told you what is the velocity at the topmost point of the projectile. Guys, at topmost point, we say this vertical component of velocity is 0. But horizontal component remains same, that is u cos of theta. Initially, it is u cos theta and it will remain same throughout the entire journey, that is u cos of theta. So we say this horizontal velocity remains same. So we say at topmost point, topmost point, I say velocity is u cos of theta. At topmost point, velocity is u cos of theta. Now guys, according to the question, they are saying that, sir, it has got a velocity of root 3 by 2 times of u. Okay. Now, according to the question, we say at topmost point, we say velocity is given as, that is root 3 by 2 times of u. This is according to the question. This is according to the concept. Don't you think that, sir, we can equate both the two equations? So I'll write over here. So I can say in this particular case, that is u cos of theta will be equals to, that is root 3 by 2 times of u. Now this u and u will cancel. Cos theta is root 3 by 2. When is the value of cos theta as root 3 by 2? I'll say, sir, cos theta is equal to, we say, cos of 30 degrees over here. Why? Because root cos 30 is root 3 by 2. So I can say over here in this particular case, theta will come out to be 30 degrees. Now, guys, we got the value of theta. What we are supposed to find? Let's find out the range now. Now find range. Now let's find the range. Now let's find the range. So I can say, sir, range is equal to, that is u square sine of 2 theta divided by g. This is the formula of range that we have studied. Now I can say this range will be simply u square, u is the initial velocity, that is u square, sine of 2 theta, sine of 2 into, what is the value of theta? Theta is 30 degrees over here, and divided by, we say, g. So r will be equal to sine of 2 into 30 is 60. Sine 60 is root 3 by 2. So u square divided by g, and this is a root 3 by 2. This is the answer to this particular question. This is the answer to this particular question. That is u square divided by g, root 3 by 2 multiplied by root 3 by 2. I hope this is crystalline clear. Guys, let me know in the chats. Everyone means everyone. Okay? Is this crystalline clear? Is this crystalline clear? Is this crystalline clear? Please tell me in the chats. Ladies and gentlemen, boys and girls. Is this crystalline clear? Then we will move on to the next topic. That is conditions of maximum horizontal range. Conditions of maximum horizontal range. Okay? Yes. See guys. Let's suppose I say you are launching a projectile over here. I say you are launching a projectile over here. Okay? Sir, if you are launching a projectile, if you are throwing a projectile, sir, how can I get the maximum range? This range should be maximum. It should go very far. Okay? What is the condition for that? What is the condition for getting the maximum horizontal range over here? Okay? Guys, see. We say, as we know, maximum range is what? Sir, how should you throw a projectile so that the range comes out to be the maximum, so that the range, it should go very far. So we know what is the formula for range. R is equal to, we say u square sine of 2 theta divided by g. This is the general formula for the horizontal range. Okay? Yes. Now guys, you want this range to be maximum. See, this g is constant. Let's suppose you are throwing two projectiles, one projectile, another projectile, and you are throwing them with the same speed. So can I say in that particular case, for those two projectiles, u is also constant? Why, sir? Because you are throwing the two projectiles with the same speed. If you are throwing this and this, both these projectiles with u and u, so means u will become constant for these two. G is constant, u is constant. So I can say this range depends depends, we say upon, we say sine of theta, or I can simply say sine of 2 theta. Okay. This range depends upon sine of 2 theta. This range depends upon sine of theta. Okay. Yes. This range depends upon sine of theta. Now guys, I would want you guys to focus over here. This r depends upon the sine of theta. So if you want range to be maximum, then the value of sine theta should be maximum. So if sine of theta is maximum, then range will be maximum. As simple as that. If sine of 2 theta is maximum, we say range is maximum. And guys, you might have heard one thing. When is the value of sine theta as maximum? Sir, maximum value of sine theta is 1. We say as maximum value of sine is 1. Sir, maximum value of sine is 1. So I can say in this particular case, so here sine of 2 theta, because here it is given sine of 2 theta, it should be equal to 1. If sine of 2 theta becomes equal to 1, then I can say in that particular case the range will come out to be maximum, because this is the maximum value of sine theta. Now can I say when is the value of sine theta as 1? Sine 90. So I'll write sine of 2 theta is equal to, I'll write over here sine of 90. So I'll write, sir, sine will go. So this 2 theta is equal to 90. 2 1s are 2 45s are. Theta will come out to be 45 degrees. So what I'm trying to say in this particular case is, if you throw a projectile at an angle of 45 degrees, we say range will come out to be maximum. Why? Because at 45 degrees, sine of 2 theta will be 1. Because 2 into 45 is 90. Sine 90 is 1. So if maximum value of sine is 1, so you'll put the maximum value of sine over here. You'll get the maximum range. I hope this is clear. Or simply remember, sir, if the value of theta is 45 degrees, the range will come out to be the maximum. So we say, so if theta is equal to 45 degrees, then range of a projectile is maximum. Then range of a projectile is maximum. Okay. Now guys, see. Sir, how much is that maximum range? Could you please tell us what is the maximum range? Now. Guys, see. I can say, sir, R max I'll write over here. That is u square sine of 2 theta. So I'll write over here, that is u square sine of 2 into what is the value of theta? Put the value of theta as 45 over here, because at 45 range is maximum. And divided by, I say g over here. 2 into 45 is 90. Sine 90 is 1. So maximum range, R maximum, will come out to be u square divided by g. So this is the value of maximum range. Please tell me in the chats, everything is crystalline clear. Please, I need the signal from every single student. Everyone means everyone, guys. Let me know in the chats if everything is crystalline clear. Everyone. And do like this particular session. Now, if R is the maximum horizontal range of a projectile, then the greatest height attained by it is. We are supposed to find the greatest height, maximum height. See guys. It says that if R is the maximum horizontal range, we say if R is the maximum horizontal range, if R is the maximum horizontal range, now we say then we can say theta is equal to 45 degrees, because Maximum range is only possible. Maximum range is only possible when theta is equal to 45 degrees. Okay. Now, we are supposed to find what is the greatest height. Guys, see, as we know, as I can say height is equal to r, we can say tan of theta divided by 4. So what is the value of theta over here? That is 45. So I can say r is equal to, h is equal to r. I'll write over here tan of 45 degrees divided by 4. Tan 45 is 1. So in this particular case, h will come out to be r divided by 4. So this will be the greatest height attained by the projectile. At maximum range, this is the greatest height attained by the projectile. Now take a look over here. Now take a look over here. Now take a look over here. See guys, range for two different angles is same. A range for two different angles is same. Range for two different angles is same. See guys, what does this actually mean? What does this actually mean? Let's suppose I am throwing the two projectiles over here. Let's suppose I am throwing the two projectiles over here. Okay. Let me show you. This is the first projectile and this is the second projectile. This is the second projectile. Okay. Guys, see. This first projectile is launched at some angle. This is launched at some angle. And this second projectile is launched at another angle. Or let me show you over here. Let me show you over here. So we say, yes. Guys, see, this projectile is launched at some angle. This projectile is launched at some angle. Okay. And in this particular case, my dear friends, if I am saying, let's suppose this is launched at an angle of theta. And if this is 90 minus theta over here, guys, we say, if this is having the range R1 is equal to R, this will be also having the range R2 is equal to R. Means, sir, range for two different projectiles is same. Yes. If you are throwing this projectile at an angle theta, another projectile you send or you throw at 90 minus theta, both will have the same range. Both will have the same range. Let me show you. Let me show you. Guys, let me show you. We say for this, let's talk about R1. Well, how to find the range of a projectile? Sir, range of a projectile is simply, that is u square sine of 2 theta divided by g. This is the formula? Yes. Let's find this, range of this. So I'll write R2 is equal to. So that is, and let's call this as R. Sir, this is equation of this. Let's suppose we are throwing this with u, we are throwing this with u. So this is u square sine of 2 into. What is the angle over here? 90 minus theta. Instead of theta, I'll write 90 minus theta divided by, we say, g. So I'll write this R2 in this particular case, that is u square sine of 2 into 90 is 180 minus 2 theta divided by g. Guys, sine of 180 minus theta is how much? I say sine of theta. And sine of 180 minus 2 theta is how much? We say sine of 2 theta. So I'll write over here, this R2 will be u square sine of 2 theta divided by g. Even if you keep the angle, if you put the angle as 90 minus theta, then also the range is coming out to be, we say, sir, R. Because here you see range is exactly same. So means at theta and 90 minus theta, range is same. So I'll say over here, so at theta and we say 90 minus theta, I'll say range is same. Range is same. And at theta and 90 minus theta, we say range is same. Now guys, If I say, let's suppose theta is equal to 30 degrees. At what angle range will be same? We say, sir, another will be 90 minus 30. How much is that? That is 60 degree. Means 30 degree and 60 degree range will be same. If I say theta is equal to, we say 10 degrees. So at what angle range will be same? 90 minus 10, that is how much? We say, sir, 80 degrees. So I say 80 degrees. At 10 and 80 range is same. Okay. If I say this theta is equal to, let's suppose, 20 degrees. At what angle range will be same? 90 minus 20, that is 70 degrees. So at 70 and 20 range is same. At 80 and 10 range is same. At 60 and 30 range is same. Accordingly, you can see further different combinations over here. Okay. Now, this is the important question. Which I would want you guys to focus over here and solve this particular question. See, guys, what is given over here? A projectile is fired at an angle of 45 degrees with the horizontal. You have got a projectile over here. You have fired a projectile over here at an angle of 45 degrees. Okay. Let me show you over here. You have fired a projectile at an angle of 45 degrees. So this angle is given as 45 degrees. Elevation angle of the projectile at the highest point will be, guys, let me show you what is this elevation point. This is the topmost point. This is this point, launching point. I want you guys to join these two. Okay. Now, angle between this line and this horizontal axis, this is what we call the angle of elevation. That is alpha. You are supposed to tell me what is the value of this alpha. Guys, see, if we draw a line over here, don't you think that, sir, this is the maximum height? And from this point to this point, this is range. Don't you think that this is r divided by 2? This is half of the range. From this triangle, you can see over here. In this particular case, theta is given as 45 degrees. We are supposed to find the value of alpha. Okay. How can we find the value of alpha? So I say over here, sir, this tan of alpha, I can simply say, that is this perpendicular by base in this triangle I am saying. What is this perpendicular? That is h. And what is base over here? That is r by 2. So this will be simply, that is 2h divided by r. So this came out to be tan of alpha. Cool? Absolutely cool. 100%. Now guys, this h, I need to change over here because I don't require this h over here. See guys, we say as we know. Is there any formula between h and r? Yes. Sir, this h is equal to r tan of theta divided by 4. I know this formula. I would want you guys to put up this in this particular equation. Let's call this as equation first. I say, put in the equation first. I would want you guys to put up this in the equation first. If you put this in the equation first, I can say tan of alpha will be, here it is 2 divided by r. Instead of h, I would want you guys to put up this over here. That is r tan of theta divided by, we say, 4. Now 2 1s are 2 2s are 4. Now this r and this r will cancel over here. So I'll say, sir, tan of alpha is equal to tan of theta divided by 2. Now what is the value of theta? Theta is given as 45 degrees. So I can say in this particular case, tan of alpha is equal to tan of 45. Tan of 45 divided by 2. What is the value of tan 45? We know value of tan 45 is 1. So I'll put up over here. So tan of alpha will come out to be 1 divided by 2. So can I say alpha will be tan inverse of 1 by 2. Alpha is tan inverse of 1 by 2. Is this clear? Is this clear? Is this clear? I hope this question is also sorted. Yes. The speed of a projectile at its maximum height is half of the initial speed. At its maximum height is half of the initial speed. The angle of projection is, you guys are supposed to tell me what is the angle of projection in this particular case. Come on, guys, give it a shot. Let me know the answer of this particular question. Okay, what is the answer? Let me know in the chats, everybody. At topmost point, at maximum height, it is saying its speed is half of the initial speed, that is u by 2. See, let's suppose you have launched a projectile over here. It says that at topmost point, how much is the speed? We say, sir, at topmost point, it is saying u by 2, because if you are launching it with velocity u. And also we know at topmost point, what is the speed? That is u cos of theta. This is according to the concept. This is according to the question. So can I say in this particular case, u cos of theta will be equal to u by 2. This and this will cancel. So cos of theta will be 1 by 2. When is the value of cos theta as 1 by 2? Okay. So when it is 60 degrees. So cos of theta will be equal to cos of 60. So I can say theta will be equal to 60 degrees. Okay. Great. Next. Let's take a look at this. That is horizontal projectile. Okay. Now guys, take a look over here. Horizontal projectile. What does this horizontal projectile actually mean? What does this horizontal projectile actually mean? I would want you guys to focus over here. See guys, when it comes to the horizontal projectile, it means you are launching a projectile from certain height. You are launching a projectile from certain height. You are throwing a projectile from certain height over here. Okay, this is what we call the horizontal projectile. So it will follow this particular path. We say when a projectile is launched, from certain height, horizontally, it is what we call the horizontal projectile. Okay. Now guys, you know this projectile motion is the combination of horizontal and vertical motion. So I'll write this as horizontal motion over here. I'll write this as vertical motion over here. Guys, see, we say initially, let's suppose you are throwing it with a velocity u. I would want you guys to focus over here. Can you tell me what is the initial velocity in x direction over here? Sir, this velocity is completely in x direction. No doubt, sir, when you throw it, sir, because of the gravity attracts it. So it will follow this particular path. It wanted to go straight, but because of the gravity, it will follow this particular path. So initial velocity in x direction is completely u over here. This is the initial velocity in x direction. And could you please tell me initially what is the velocity in y direction? Sir, initial velocity in y direction is 0. Why? Because there is no velocity in y direction. Complete velocity is in the x direction. The whole velocity is in the x direction. Could you please tell me, is there any force in x direction? We say force in x direction is 0. So means acceleration in x direction is 0. Because no force is acting in the x direction, okay, in case of a projectile motion. But when it comes to y direction, force is in y direction is gravity. Okay, and I'll write that is m into g. And what is the acceleration in y direction? That is g. We have already discussed it. That is g. Okay, and we take it minus g always. Now guys, tell me, listen to me very carefully. Let's suppose when the particle reached this particular point over here. Okay, okay. I say at this particular point, let's suppose it has velocity v. This velocity will have horizontal component, that is vx. This velocity will have vertical component, that is vy. And let's suppose this angle over here is alpha. It is making the alpha angle with the horizontal, this velocity. Now, can you tell me what is the velocity in x direction finally? Guys, see, we say vx is equal to u plus a into t. Use this in x direction, use this in x direction. Can I say velocity in x direction finally? This velocity I am saying. Initial velocity in x direction is u. What is the acceleration in x direction? That is 0. So this term will become 0. So it is u. So it is ux. So means here also, velocity in x direction remains constant. But when it comes to the y direction, so I say vy is equal to uy plus ay into t. Let's use this. So we say, sir, velocity in y direction finally. So I say initial velocity in y direction is 0. So acceleration is minus and acceleration is minus g into we say, sir, t. So this velocity is minus gt, this velocity is ux. Okay. Okay. I hope this is clear. Also, you can find the value of this tan alpha. Also, guys, see. This is over here velocity v. This is the horizontal component, that is vx. This is the vertical component, that is vy. And this is alpha. Don't you think that we can write this tan alpha is perpendicular by base? So I can say tan of alpha is, that is we say vy divided by vx. Perpendicular by base. Now how much is vy? Vy in this particular case is, I'll write minus gt divided by, how much is ux? That is u. Minus gt divided by u. Guys, is this clear till over here? Is this clear till over here? Okay. Okay. Even you can find this velocity also. Okay. Okay. I'll find this velocity also. Also, guys, we can say this velocity will be simply, that is vx into I cap plus vy into j cap. This is how we can find it. So this velocity will be, what is the value of vx? What is the value of vx? Vx is ux only, that is u only. So this is u I cap and vy is minus gt into j cap. Okay. You can write it something like this. This is the velocity. And you can find the magnitude of this velocity also. That is under root of u square plus, we say minus gt whole square. This is the velocity in this particular case. Let's now find the time of flight. Guys, what is this time of flight? Let me show you over here. Let's suppose this is the building that we have got over here. Okay. And in this particular building, you are throwing a projectile over here. Okay, from this building you are throwing a projectile. So we say it follows this path. How much time it will take to complete its journey? Okay, so that is what we call the time of flight. How much time it will take from this point to this point? I would recommend you to use one equation. We say I would say S is equal to ut plus 1 by 2 at square. And use this equation in y direction, and y direction. Okay. Let's suppose the height of this tower is, let's suppose h. The height of the tower is, let's suppose h. Okay. Okay. Now. So I say, guys, you are supposed to use this equation from this point to this point. Okay. Use this equation from top to bottom. From top to bottom. Okay. Yes. Now, how much is the displacement in y direction, guys? So I say that is h. What is the initial velocity in y direction? Sir, we have launched it with a velocity u horizontally. Initial velocity in y direction is 0. So this is 0 into, we say, sir, t plus 1 by 2. What is the acceleration? Acceleration is minus g. So I'll write that minus over here. 1 by 2 g t square. Okay. Now, guys, see. I have told you so many times, if the ball comes down, take the height negative. If it goes up, take it positive. So I'll write minus h over here. Now I can say this minus h is equal to minus 1 by 2 gt square. Minus and minus goes. Okay. Now this goes over here. This is 2h divided by g will be t square. So from this you can say this t will be under root of 2h divided by g. So this is basically the time of flight. How much time this projectile will take from this point to this point. Now let's move on to this one. A range of a horizontal projectile. Range of a horizontal projectile. Guys, see. Let's suppose you are throwing this projectile from this building. Okay, you are throwing this projectile from this building. It will follow this path. How far it can go? That is what we call the range. Okay. And I would recommend you to use S is equal to ut plus 1 by 2 at square in x direction. Okay. Use this equation in x direction. Now, how far it can go, that is what we call the range. That is the horizontal displacement is equal to. Now, guys, see. Initial velocity in x direction. Guys, here this x direction has u initial velocity. Complete velocity is in the x direction only. So that is u into time is, we say, sir, t. It is taking time t from here. Then we say plus 1 by 2. Acceleration in x direction is how much? That is 0 into t square. So this whole term will become 0. Can I say in this particular case, this range will come out to be u and. What is this? This is u into t. Now, guys, what is the time period that we recently got? That is under root of 2h by g. So you can write this also, that is u, and then we say under root of 2h divided by g. This is the formula for the range that we have. Okay, this is the formula for the range. Now this is the question, that is alpha. How to find this alpha? That I recently told you. Tan of alpha is simply, that is perpendicular divided by base, that is gt divided by u. Simply gt divided by u. Now, guys, ball is projected with 30 meters per second in horizontal direction from some height. Find time when it is making 45 degrees from the horizontal. Guys. It is saying that we have launched a projectile from certain height. From this height, we have launched this projectile. Okay. Now, this projectile will, let's suppose, follow this particular path over here. This projectile will, let's suppose, follow this particular path over here. And It is saying that ball is projected with 30 meter per second. So this velocity is given as 30 meter per second in horizontal direction. Find the time when it is making 45 degrees. Guys, let's suppose here. This ball is making, let's suppose 45 degrees with the horizontal. Okay. We are supposed to find what is the time at this particular point. Easy question. Easy question. Okay. Guys, see, if this is V, can I say this is Vx and can I say this is Vy? And what is the value of Vx? That is U. What is the value of Vy? That is G and T. Tell me guys. Can you tell me the value of tan of 45? Guys, tan of 45, or we say this is tan alpha. That is this GT divided by U. So I can say that is GT divided by U. What is tan 45? That is 1. Okay. So this is 1 is equal to G is how much? That is 10. And this is T, and what is U? U is 30. U is given as 30. Okay, this and this will go. So T will come out to be, that is 3 seconds. So we say after T is equal to 3 seconds, the ball will be making 45 degrees with the horizontal. Ball will be making 45 degrees with the horizontal. Okay. One more question you have got over here. A plane is moving with 500 meter per second. There is a plane, okay? This plane is moving with 500 meter per second. 500 meter per second. This is its velocity. This is the value of U. At a height of 2000 meters. So this height over here is given as, H is given as 2000. At what distance should I drop the bomb so that it hits the target? Let's suppose it is dropping the bomb over here. Okay, this is the bomb. Okay. Now, here is the target. It has to hit the target. Do you think that when the plane is over here, then it has to launch this particular bomb? No. It has to drop this particular bomb over here? No. Because if you drop it over here, it will fall and it will hit over here. So it has to basically leave it before. So it has to leave it somewhere around over here. Then only this bomb will follow this projectile path and it will hit the target. So we are supposed to find at what distance it should basically leave this bomb. So kind of we are supposed to find the range over here. What is the range of this projectile? Okay. So how to find the range of the projectile, sir? When it comes to the range, we say U under root of 2H divided by G. Everything is given. Everything is given in this particular case. So I say over here R is equal to, what is the value of U over here? That is 500 under root of, then we say 2. How much is the height? Height is 2000. 2000 divided by, we say G in this particular case is 10. Okay. And if you solve it, it will come out to be 10,000 meters. 10,000 meters, that is 10 kilometers. So means you have to initially leave it before 10 kilometers, then only it is gonna hit the target. It will hit the target. Okay, this one. Let's suppose we have got this over here. A particle starts its motion from the origin, moves in the xy plane with a constant acceleration alpha and y. Its equation is its velocity component. This is your homework. Okay, I'll give you some questions as homework. I would want you guys to solve these questions, okay, from your end. And then another question says that a body is thrown horizontally with a velocity root 2gh from the top of the tower of height h. It strikes the level ground through the foot of the tower at distance x. Find the value of x. You are supposed to find the range over here. This is also homework in this particular case. Easy questions. Okay, here you have to find the range. And last one, yes, this is a good question over here. Now guys, I'll give you the idea of this question. I would want you guys to focus over here. See. A ball is projected upwards from the top of a tower. अब देखो, now guys see, it says that a ball is projected from the top of a tower. This is a tower. This ball is projected upwards from the top of a tower. Okay. With a velocity of 50 meter per second. This velocity is given as 50 meter per second. Making an angle of 30 degrees. So it is making an angle of 30 degrees with the horizontal. The height of the tower is 70 meters. Height is given as 70 meters. After how many seconds from the instant of throwing the ball will reach the ground? We are supposed to find the time. Now see how can we find the time over here. If this ball we are throwing with a velocity of 50, guys, which component of velocity this will be? Sir, this will be 50 cos of 30. Why? Because if this is u, this will be u cos 30. Because theta is from this side, so u cos 30. 50 cos 30. And can I say this is 50? What is the value of cos 30? That is root 3 by 2. 2 ones are 225s are. So this will come out to be 25 root 3. So this is what we call the ux. And if I talk about the velocity uy, so can I say uy in this case will be that is 50 sine of 30 because this will be the sine component? Yes, sir. Now tell me sine 30 is 1 by 2. So this will come out to be 25 meter per second. So uy is 25, ux is 25 root 3. Now it will basically follow this particular path. It will follow the path something like this and it will hit the ground. Okay. Now guys, how much time it will take in this entire journey? That is what we are supposed to calculate over here. See, I say use S is equal to ut plus 1 by 2 at square in x direction, in y direction. Okay, I would want you guys to use this equation in y direction. Okay, guys, see. So means you have to use it from top to bottom. So we say from top to bottom. Now, if we use this particular equation over here, guys, if we use this particular equation over here, if we use this particular equation in this particular case, see, I say this sy, what is the value of sy over here? Sy means, sir, how much is the displacement in y direction? If you are throwing the particle over here, so whatever the distance it will cover, we don't have to focus on that. We have to see how much displacement it will do in y direction. That is only 70 meters. So displacement in y direction is only 70 because it is between the initial point and final point. Final point is ground. Initial point is this. So it is equal to initial velocity in y direction. Guys, how much is the initial velocity in y direction? That is 25. So I'll write over here 25t. Okay. Yes. Now tell me one thing in this particular case, my dear friends. So this will be, sir, 1 by 2 and I'll write minus 1 by 2 because acceleration is negative, minus 10. So 1 by 2, we'll take acceleration as minus 10 meter per second square, 10 and this is t square. 2 ones are 2 5s are, okay. And this ball is coming down over here. So we'll take this as minus, we'll take this as negative. Okay. This height will take as negative. Now tell me in this particular case, how are we supposed to write it? Guys, this will be minus 5t square. Okay. So do one thing, take it over there. So this will be 5t square. If you take it over here, it will become plus. Okay. Now if you take it over there, it will be minus 25t. Because it is plus over here, it will become minus. And already from that side, this is 70 is equal to 0. Now take this 5 common. So I'll write, sir, this is t square minus 5 into 5 is 25. So 5t minus 14 is equal to 0. So this will be the equation, quadratic equation. And if you solve this quadratic equation, value of time will come out to be 7 seconds. Oh, okay. So we say it will take 7 seconds from this point to this point. Okay. Great. Now guys, if you have not liked this session yet, I would want you guys to hit the like button as soon as possible, and do let me to do tell me in the comments later on when I end the live stream how was the session. Okay, so my dear friends, I would want you guys to focus over here. What is that? What is that? The focus is we say lowest ever price for the NEET UG subscription. Okay, now guys, right now if you take the NEET UG subscription, it is only for, we say, 4,000, it is only for 4,999 rupees. Okay, so with the help of this plus subscription, you will be having the access to all the batches, not just one batch, to all the batches whatever is running in the inside Unacademy. If you are in class 11th, class droppers, NEET, whatever it may be, you can have the access to all the batches. Okay, you can have the access to test series also. You can have the access to, we say, exclusive mentorship sessions also. Okay, and there is one more thing, that is Unacademy Pro. Lot of students want to basically learn online, but they want to take the test series offline. They want to revise offline. Then I would recommend you to go with the Pro, because all of those features are present in the Pro. Like you have offline revision classes, offline test series, offline doubt solving, live mentorship sessions, physical notes. Okay, so these can be done in our offline center. So you guys can basically go and you guys can check it out. So do like this particular session, do like this particular session. Okay, if you have not liked it yet, do like it as soon as possible, and please let me know in the chats what is the next chapter that I must start. What is the next chapter I must start? Let me know in the comments later on. Okay, so that's all for today. Thank you so much guys. With this, I'll take a leave. See you guys in the next session.